Okay, everybody, this is going to be a review for your stoichiometry quiz, which is tomorrow. And so this is a replica of your quiz. Just we have different equation, we have different numbers for you, but it's going to be exactly the same as far as the format. So here's what we're going to have. You're going to have two equations, and you're going to have two problems to go with each one. I'm just going to start with the top one, and that's all I'm going to work with you today. So let's read the first question. How many grams of iron gas will be used to produce 28.4 grams of hydrogen gas? Well, here we go. So looks like we're going to label our A over here and label our B over here. So let's put that up there in the equation also. Shout out to McLaren today. She asked me to do that for her, so I did. So iron gas, here we go. There is our B, and this is going to be our A. And so we're going to set up the problem. Using your Stoich flow chart is really, really important. Anyway, we start with 28.4 grams of hydrogen gas. And so we need to go find out, what are we going to look for? Grams of iron gas. So there we are. So this is a mass-to-mass problem. So you are now used to mass-to-mass problems. So now we're going to put, using our flow chart, between steps 1 and 2, 1 mole over the molar mass of your hydrogen gas, which is your A, and that's going to be 2.02 grams of H2, okay? Now we look for the mole ratio. That goes right in the middle there. And so the moles is going to be B over A. The moles of iron gas is going to be 2. It is a balanced equation. And the moles of A is going to be 3. And there you go. There's your mole ratio. Last thing you have to do, add the molar mass of iron over the moles of iron. And so when we look at that, iron is going to have a molar mass of 55.8 grams over 1 mole of iron. And there's your setup for it. So you're going to multiply the 28.4 times the 2 on top and times that number right there. And then you're going to divide by the numbers on the bottom here. So we'll multiply everything across the top, multiply everything across the bottom, and then divide the two numbers, okay? And for the second part of that, we want to see how many moles of iron will be used to produce 8.15 grams of iron 3 oxide. So our A is going to be our iron 3 oxide, and that is right there. And our B is going to be moles of iron, and that's going to be our B right there. So we can go ahead and set up a problem really quickly. And we write down our given, which is 8.15 grams of iron 3 oxide. So it's Fe2O3. And then we have our B is going to be moles of iron, okay? And so what we have to do now is you have to put, this is a mass to moles problem. So this is mass to moles, okay? I'm not going to do all of it, but what I'm going to do is I'm going to put the molar mass of Fe2O3 here with 1 mole of Fe2O3. And then the only thing left that you have to do with a mass to mole problem is to do your mole ratio, set up your mole ratio. And that's going to be moles of B over moles of A. The moles of B is the iron, which is going to be 2 moles. And our A is our Fe2O3, and that's 1 mole there. And so now, all you have to do is take that number, 8.15, multiply it by 2, and divide it by the molar mass of Fe2O3. And there you have how you set up a moles or mass to moles problem in stoichiometry. Good luck on the quiz tomorrow.